Hey everyone, Professor Adjvan here with episode 20 in the linear series, where we're going to look at graphing two variable linear inequalities. We're going to be graphing these on the XY coordinate system. They look like the problems that are on your screen now, and these are the three examples that we're going to be doing. So if whatever you're currently working on look like these types of problems, then this is the correct video for you. Let's go ahead and jump into it. So to graph two variable linear inequalities, we're really going to graph them very similar to the way that we graphed the normal linear equations that were y equals. But now, with them being two variable linear inequalities, instead of having y equals, we have y is greater than or equal to, or y is less than or equal to. We have that inequality symbol here. All right, but we're still going to start the same way. We're going to look at the y-intercept. Okay, so here the y-intercept is 4. It's going to be my starting point. My slope is negative 1/4, so we're still doing the same thing. I'm going to go down 1 and over 4. Down 1 and over 4. And so on. And we can go the other way. We can go up 1 into the left 4 to get some more points to be more accurate. Alright, so here's where things get a little bit different. If you see that this is a greater than or equal to or less than or equal to, meaning that there is the line underneath these, we're going to graph this with a solid line. Right? So just like we did when it was y equals, a solid line. I'm getting a little off. Okay, now that's not it, because this is saying y is greater than or equal to. Right? So it's not only this line, it can be everything greater than this line. So this is where having maybe a colored pencil might be beneficial because we need to do some shading. Okay, so this is greater than, so everything above this line we want to shade. So I would shade everything above it. Okay, let's look at another example. Y is greater than or equal to negative 2x plus 3. So again, we start at the y-intercept, 3, and then we use our slope, negative 2. So I'm going to go over 1 and down 2. Right, down 2, over 1, and so on to get a collection of points to make our line as accurate as possible. And we can do the same thing going to the left. We can go left 1 up 2 to get some more points. Again, this is greater than or equal to. So we're going to do what we've been doing and draw a solid line, connecting all of the points using a straight edge if we have one. There we go. And now this is greater than. So what I want to illustrate at this time is how to determine if it's greater than or less than. How do we determine what's above or below the line, because it can get a little iffy if our slope is very steep with what is above and what is below. So a trick is to pick any spot on the line, doesn't matter, and just draw a vertical line. Right, so this is greater than, so the thing above this line, right, this intersection, is going to be where we shade. So everything above, which is this side of the line, is going to be where we shade. Alright, so just a little trick that might come in handy depending on what your problems look like to help determine what is above the line and what is below the line. Alright, let's look at our final example. In this case, we have y is less than, just less than, not less than or equal to, 2/3 x minus 1. Alright, so let's see how this changes. So we're going to start at negative 1. Right, that is our y-intercept. And our slope is 2/3. We go up 2 and over 3, right? Up to over 3. Uh, Up to and over 3. And we can go the other way. We can go down to and over 3, down to and over 3, and so on. Now, with this being less than, not less than or equal to, instead of doing that solid line like we did in the last couple of examples, we're going to do a dashed line. And this designates, if we only see the line, that our equation is not equal to this line. That we are less than this line. We aren't equal to it, we're only the things below it. So we still need a shade, and we need to shade the things below it. So below the line is everything below it, just like this. Alright, now, your teacher might be different. Your teacher might prefer you to always use a solid line. And your teacher might say, let me just go to another page. Your teacher might want you to always use the solid line, regardless if it's less than or equal to, or if it's less than, right? And for less than, they would want you to, instead of using the dash line, use the solid line and then shade, but don't touch the line. And then if it was less than or equal to, right, solid line and shade, but touch the line. I don't like this method. I think it gets very messy and very minute if your shading is touching the line or not. I don't like it at all. I recommend the other way, but if that's the way that your teacher is teaching it, where you need to always have a solid line and you're either touching it with your shading or not touching it, that's how you would do it. But it's the same approach. All right, but I much prefer the dash line for less than or greater than, and a solid line for less than or equal to and greater than or equal to. That's my personal preference. All right, so that is graphing two variable linear inequalities. I hope this helped. If you found it helpful, consider giving the video a like and consider subscribing to the channel. Thanks for watching, good luck, and we'll see you in the next one.